Welcome back. All right, so we broke existing rock down via a process called weathering. Now those little bits that are broken off, those are called sediments. Sediment is rock that has been fragmented, transported, and deposited as a result of combination of mechanical and or chemical weathering processes. There are different classifications of sediment. There's biogenic sediment, chemical sediments, and clastic sediments. These will later dictate the type of sedimentary rock that is created from the sediment. So biogenic sediments are any sediment, pile of broken down stuff that is composed primarily of plant and animal remains. That include broken down shells, bones, teeth, pieces of wood, roots, leaves, or even microscopic oceanic materials that when they die and decay leave behind their little calcium-based skeletons and can break off into pieces and then form little sediments. So you can get biogenic sediment. So again, sediment with some sort of biologic content in it. Chemical sediments formed by precipitation of minerals dissolved in water. And it's caused mostly by water evaporating. So imagine it rains in an area, say in the surrounding mountains. And as the rain kind of hits the surrounding mountains, it might break down some material, weather some material, and that rainwater pools down in the bottom valley below. Well, in some of that material that was broken down, there might be some minerals in there. As the water evaporates away, the minerals kind of settle out, sometimes forming some sort of crystalline structure, sometimes not, but that is chemical sediments. So when precipitation, again, can occur within an ocean, a lake, a cave, or where a lot of hot springs flow out onto Earth's surface, where precipitation means where it comes out of solution. Precipitation, as it refers to weather, is water falling out of the sky. Precipitation, as it pertains to sediment, is when the kind of mineral sediments fall out of the water as the water evaporates away. Some chemical sediments can include halite, which is the fancy mineral name for salt, gypsum, and travertine, chemical sediments. And those two, biologic and chemical, are kind of the least common of sediments. Not that they're not around, they're just the least common. The most common would be clastic sediments. These are sediments formed from fragmented rock and mineral debris. It's not dictated by chemical or mineral makeup, and all of these look like different pieces of minerals or rocks, which they are, but we're not kind of going to distinguish clastic sediments by type, but we are going to distinguish them by shape, how round they are, or how angled they are. Are they all the same size? Are they a bunch of different pieces? That's called sorting. And the size of the sediments themselves, the size of the pieces themselves. So when looking at roundness of a clastic sediment, is it kind of very smooth and rounded, or is it more sharp and jagged, meaning angular, or is it somewhere in between? That will dictate the sediment classification and eventually sedimentary rock. Sorting. Is it all the same size pieces? Are there very drastic size pieces? Is it kind of somewhere in between? That's called sorting. And then size, big, small. So again, types of clastic sediment is based on shape, and a big component of that is size, not composition. The biggest size of sediment would be gravel. That's the largest size of sediment. Sand is a medium size. Silt is small size, and clay is very, very small size. So like when you think clay, like molding clay or Play-Doh type stuff, clay is not the substance. Clay is describing the size of the sediment that makes up that material. So sand on a beach isn't describing, the chemical makeup of the material. It's just describing the size of the particles, size of the sediment. So clay is sediments are anything that are 0.002 millimeters and smaller, which is very, 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 very small, microscopic. Silt is anywhere from that clay size up to 0.0625 millimeters, less than 1 millimeter. So very, 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 very small, also microscopic, but much bigger than clay. Sand is anywhere from 0.0625 all the way up to a whopping 2 millimeters. That's actually something we can kind of see. So 2 millimeters is the distance between my fingernails up here. My fingernails up there. So anything up into that size is considered sand. So anything bigger, excuse me, anything bigger than 2 millimeters is considered gravel. And there's kind of separate separate categories from 2 millimeters to 64 millimeters. That would be considered pebbles. 64 millimeters to 256 milliliters. That'd be about this big. About this big. That's a cobble. And then, so anything this big, anything this size or bigger is considered a boulder. It's not describing the material, it's just describing the size of it. So, this is, if we were to compare a sand to silt to clay size particle, and we were to put these under a microscope, this is what it would look like. Obviously, sand is not that size, but if we were to just give you size comparison, if we were to look at these under a microscope, a grain of sand might look like this, and clay, very small. Silt, kind of in between. And it's so when we take this, these different sediments, and then we compress them and cement them together, we can get different types of sedimentary rock. So with compression, cementation, and time, we need time too, I guess. If you take a bunch of gravel-sized sediments and compress and cement them together, you get, for example, rocks like conglomerates or sometimes breccias. If you take sand-sized sediments, do the same thing, that would create sandstone. Silt-sized particles create siltstone. Clay-sized particles create shale or mudstone. We'll talk more about those in a couple sections. Before we move on, let me give you part of the super secret code. It is the number 52. You got me? 52. One more time. 52. So, we've broken down material, weathering, into these pieces, sediment. Now we gotta move and deposit that sediment, erosion. So that's where we're going to go to in the next section. So I'll pause here. I'll see you back in just a second.